So time series data can be decomposed into 4 different components. There's a trend, a cycle, seasonal, and irregular component. So the trend is the movement up or down. So the long-term trend is what we're trying to figure out. So trends can be stable, okay, steady and predictable. Trends can be increasing, decreasing. They can be flat. Time series lines can be flat, or that's when the variable stays the same over time. Okay, and we can find a statistical trend. We can fit this to any data series with regression analysis, but sometimes the best fitting trend isn't the best for forecasting. And we'll see how that works. This is what a trend looks like. So here's an upward trend over time. So here we have the dates on the horizontal axis and the levels of the variable, the time series variable, on the vertical axis. And a trend, this is just a linear trend. So this variable is increasing at a constant rate over time. Okay, a cycle is our long-term up and down movements around a trend. Okay, and these long-term means that these cover several time periods. For example, macroeconomic business cycles are long-term trends. Okay, where the business cycle, if you're measuring that with gross domestic product, or which is annual expenditures or quarterly expenditures, then so you can see here we have an underlying long-term trend, an upward long-term trend, but around the trend, the variable increases and decreases, increases and decreases. And with GDP data, we have a typical business cycle is when an economy expands to a peak and then it contracts. That's called a recession. So GDP falls until it hits a trough, and then GDP recovers, and that's when we have economic growth back to the previous peak. And then expansion is an increase in GDP and economic growth above the last peak until you reach another peak. Okay, seasonal variation is when you have a cyclical pattern that's less than a year. So you could have a cyclical pattern of a quarter, a month, a weekday, or some other time period. So like US GDP data, it tends to has a seasonal pattern where the first quarter economic activity is slower, and then it picks up in the second quarter, picks up again in the third and fourth quarters, and then falls back again in the first quarters. Used car sales have a seasonal pattern where sales might spike in the month of March. Okay, you might work in the restaurant business. Sales increase on the weekend. Okay. Okay, and here's what the same underlying data process looks like once we've added in the seasonal seasonality of the data. So we have this overall upward trend. You can see in here the trough and the peaks of the cycles, and within those troughs and peaks we have more fluctuations. And then finally, the irregular pattern. This is just a random disturbance. We have no idea why this is happening. So in our regression models, this is going to be captured by the error term. The error term. Okay, and so this captures anything other than trends, cycles, and seasonality. For different time series, we might be able to explain what those things are. And in that, then we're moving from a time series model into a causal time series model. And we'll talk about that later on today. And I had to pause because I saw this last bullet out. I'm not sure what that is saying right there. So I'm going to delete it. We won't worry about that. Here's what the data looks like with the irregular pattern. You see spikes and valleys. Okay, but within the same data pattern, you see the long-term cycle. We've got seasonal patterns. And the long-term trend. Okay, and the trend models, they can be additive or multiplicative. An additive model, the components, the trend, the cycle, and the seasons can be added up. And this is when the change in the dependent variable due to these factors is constant. Okay, the growth is absolute. In a multiplicative model, the trend, cycle, and seasons are multiplied together, and this is when the data you're measuring the growth or decline in percentage terms. Okay, and this should be, that applies to logs in general, but these are the way that we operationalize these models. This is with natural logs, and this is going to be the exponential model.